Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to continue with finding or using the standard normal distribution table in order to find the values for probabilities or the Z values. Okay, right. Now again, if you look at this second type of table, so in the previous video we have seen this type of table, which gives you the area from one point to the left. Now in this video we're going to look at another type of table that gives you the area from Z to the right. Okay, so this area. So and if you relate with what you have seen in integral calculus, this area here, so the area here, this area can be obtained if you integrate from lower limit z to infinity the function fz, where fz is e negative 1 over 2 z squared over 2 pi dz. So by integrating from z to infinity, so z to infinity in the right direction, you'll be able to get the area under the curve. And in statistics, the area under the curve is called probability. So this area under the curve is given inside this table here. Okay, so this is the area under the curve given inside the table. So from this, okay, inside the table is the area under the curve. Now for the values of z, so this is values of z. Z is the horizontal axis. Okay, so the value of z is given by this column here. So this is the value of z. Alright, so make sure that you are able to differentiate the values of probabilities and the values of z quantile. Okay, right, so now in this video I'm going to show you the same examples which you have seen in the previous video, which is to obtain the probabilities and to obtain the z quantile. So this is the z values. Okay, all right. Now okay, we have probability z less than 1.44. Okay, let us sketch this information or this question given here. So we know that the middle point is going to be 0, and 1.44 is the value of horizontal, the z value, which is referring to the horizontal axis. And this is at point 1.44, which is to the right of this distribution. Okay, so this is 1.44, and it is looking for the probability of z being less than 1.44. So in this direction. So what is the probability? Now you can see that the area that you're looking for is different than the area given by this table. So therefore you cannot find the answer directly from the table. You need to do some sort of manipulation. Okay, now if you this is the value of z, which is 1.44. So if you read from the table 1.44, so this is 1.4 and 4. So the answer that you will get is 0.0749. And this refers to this area. Okay, so sorry. So this area 0.0749 is referring to this area. So in order to get the answer that you're looking for, probability z less than 1.44 must be equal to 1, because the area under the curve here is 1. So 1 minus 0.0749, and you will get that the answer is going to be equal to this area that you're looking for, which is 0.9251. Okay, 0.9251. All right, let's look at the next question, which is this one. What is probability z greater than 1.44? So if I sketch this question here, so 1.44 is somewhere here. So greater than, that means in this direction to the right. So you can see that the area here matches the area given by the standard normal distribution table. So you can see that answer can be obtained directly from the table. So you just simply look at 1.44 on the Z column. So this is 1.4, 1.44. The answer is 0.0749, and this is the answer which is directly obtained from the table without you having to do any sort of manipulation. You don't have to do that because the answer can be directly obtained. So probability z greater than 1.44 is just 0.0749. Okay, next, how about the third question? So the third question here is, what is the value of z? What is the value of horizontal axis here when the probability is 0.95? So the probability is 0.95, and we know that half of the probability is already 0.5, and since it is in the direction to the left because it is being less than, so this is 0.5, and it is not enough because we want it to be 0.95. So that means my z is going to be somewhere here, so that the area here is going to be, total area here is going to be equal to 0.95. Again, you need to do some sort of manipulation because you cannot obtain the answer directly from the table, since the area shaded here is not the same as the area shaded on this standard normal distribution table. So I need to know what is the area here in order to match the area given by the standard normal distribution table. So if this area is 0.95, and we know that total area must be equal to 1, therefore the green area must be equal to 0.05. So once I have managed to get 0.05, I can now find where is 0.05 inside this table. So 0.05 is, you can take either this one or this one because both of them are equally close to 0.05. So let's say you take this one. Okay, so the answer is going to be, z is going to be 1.664. Okay, so for this one, probability z less than 1.64 is equal to 0.95. So the value of z is 1.64. Okay, next, final example is this one. Okay, which I'm going to sketch over here. So what is probability of z greater than z? So we know that greater means it's going in the right direction, and the value of probability, or the area here, is very small, so we know that it's going to be somewhere here. So this is 0, so it is going to be in this direction, very small, 0.05. So z is here, and you can directly obtain the answer from the table because the area here is the same as the area given on this table here, which is to the right. So since you know the probability, which is 0.05, you can go on and look inside the table here. Where is 0.05? You will see that it will be either this value or this value because those are equally close to 0.05. So let's say you take this one, so, or you take this one, so the answer is going to be 1.665. Okay, so therefore probability z greater than 1.65 is equal to 0.05. Alright, that's all for now. Thank you very much for watching.